Welcome to today's video. Today we're going to be focusing on factoring out the greatest common factor, also called the GCF, from a given polynomial, and we're going to show that mastery by scoring at least an 80% on an exit ticket in class tomorrow. Hopefully you have the note sheet in front of you. If you don't, take out a blank sheet of paper. That way you can copy down the notes and we can get you a fresh one tomorrow. Now, when we talk about factoring out the GCF, or the greatest common factor, we want to think of numbers that multiply. That's what a factor is. A factor multiplies to give you a number. Factoring, which is what this whole unit is going to be on, is the opposite of distributing. So normally we distribute it and we pass it through. Well, now we're going to figure out where those front terms came from. So if we look at the first one, if I have 4a7b, if I talk about 4, it breaks into a factor of 4 times 1, and I also have 2 times 2. Those are the only factors that multiply. So now I'm going to check 28. Well, 28 multiplies 28 times 1. I can also do 14 times 2. And I can do 7 times 4. Well, now, if we look at what we factored, we want to find what's in common. Well, I have a 4 and 2 in common, and I have a 4 and 2, and technically we do have a 1. When we pull out the GCF, the big key is we want the greatest. Out of everything that I highlighted, the greatest is 4. Now, when it comes to the exponents, the thing to keep in mind, if all your terms have the same variable, and it has to be the same variable, it can't be two different variables, you factor out your lowest power, or your lowest exponent. So if I look, both my terms have an a and both my terms have a b. Well, if I look at my a's, I have a 7 here, and technically I have a 1 there. That means my lowest power is an a to the first. B, they're both the same, it's b to the first, so it can be factored out. In this case, 4ab is my GCF. It's my greatest common factor, what I can take out from both of them. So if we look at our second example, again, we have 28, so it's going to be 28 times 1, 14 times 2, and 7 times 4. Well, 35 we can break into 35 times 1 and 7 times 5. If we break 49, that becomes 49 times 1 and 7 times 7. Again, we want to look for numbers that are in common. Well, they all have a 1 and they all have a 7. So, again, GCF is the greatest common factor. Well, 7 is the largest number. Now, I want to look at my variables here. My first term has a y squared, my second term has an xy, and my third term has an x squared yz. They need to all have the same variable. So if I look, the only variable that they all have is y. So part of my GCF is going to be y. Well, I have to look for the lowest power. Well, my second term has a 1, and my third term has a 1. So it is just going to be 7y to the first power. We can't pull out an x or a z because not all the terms have an x and a z. In order to pull it out, every term needs to have the same thing. Now, when it comes to adding and subtracting terms and pulling out the GCF, we're still going to follow the same steps. So I'm going to take 6 and I'm going to break it into 6 times 1 and 3 times 2. Well, if I take 3, I'm going to break it into 3 times 1. Again, we want to look for what they have in common. Well, they both have a 1 and they both have a 3. So the biggest thing is I'm going to pull out a 3 because that's my largest. Now variables, they both have an r and a t, so I need an r. Well, the lowest power of r is 1 and the lowest power of t is 1. So my GCF becomes 3RT. Now, until you get more comfortable with this, I want you to write it on the inside, 6r squared t divided by 3RT. Ooh. And then subtract 3RT over 3RT. And if we look, the bottom terms are just my GCF. This is so we can figure out when we pull that out, it's like we're dividing by it. So now we need to divide by it to get our final answer. This is what we call factoring. So 3RT stays on the outside, and on my inside, I'm going to divide my coefficients. Well, 6 times 3 is 2. R squared divided by R is 2 minus 1, which gives me R. T to the first divided by T by the first, well, 1 minus 1 is 0. Minus 3 divided by 3 is 1. R over R cancels, and T over T cancels. So my final answer is 3RT times, in parentheses, 2R minus 1. Now, if you wanted to check yourself, use the distributive property like we have in class and distribute 3RT throughout the two terms. If you do, multiply your coefficients and add your exponents, you'll get 6R squared T minus 3RT. Now, the next one. We have 3 terms, but we're still going to treat it the same way. 8 breaks to 8 times 1 and 4 times 2. 24 breaks to 24 times 1, 12 times 2, 8 times 3, 6 times 4. And then in this case, I have 16, which breaks to 1 times 16, 2 times 8, and 4 times 4. Well, I want to look for the greatest, and in this case, 8 is going to be the biggest number they all have in common. So my GCF starts with an 8. Well, they all have a P in it, and my lowest power is 1. They all have an R in it, so my lowest power is 1. So now, I'm going to take each term and divide it by my GCF. So by 8PR, 24PR cubed over 8PR plus 16PR over 8PR. Again, our GCF stays outside the parentheses, and inside we're going to divide our coefficients and subtract our exponents. So I'm going to be left with 1PR minus 3R squared plus 2. This is your completed factor form. Your GCF is outside and everything left on the inside. So now if we look, again, 36 and 48. The more you do this, the easier it is to be able to see the GCF. In this case, I know 12 goes into both of them, so I'm going to have 12. They both have an X. The lowest power is 1, and they both have a Y, so the lowest power is 1. So now I'm going to divide each term by 12xy. My GCF stays out in front. 36 divided by 12 is 3. The x's cancel, and we're left with 3y minus 48 divided by 12 is 4. X squared over x is just x, and the y's cancel. So my final answer becomes 12xy times the quantity of 3y minus 4x. The way to know you're done is that whatever is left in parentheses, there is nothing else that you can pull out. Now, our last one. Again, the more you do this, the better you'll get at recognizing it. I'm going to pull out a 5, and if I look, all my terms have an x, so I am going to pull out an x, and the lowest power is 1. I'm not going to pull out a y, though, because my last term does not have a y in it. So now I want to divide everything by 5x. So my GCF of 5x stays on the outside. Well, now 5 divided by 5 is 1. X cubed over x becomes x squared, and y squared stays. Plus 10 divided by 5 is 2. Well, x squared divided by x is just x. We're going to keep the y. Plus 25 divided by 5 is 5, and the x's disappear. So that is my entire factored problem. Make sure your answers are still in alphabetical and descending order. All of them have been so far, except the previous one. But the big thing we want to keep, make sure if you're going to switch the previous one, that negative 4 stays together and it becomes negative 4 plus 3y. Now, to help better prepare us for the rest of the unit, we also want to talk about something called factor by grouping. Now, if we do factor by grouping, I'm going to move the problems just a little bit so we can write a note to ourselves. When we do factor by grouping, we want the same in each parenthesis. And I'll explain what that means as we go through these. But make sure you copy that down so you don't forget. When we do factor by grouping, we want the same in each parenthesis. Now, grouping means we're going to group them together. So I'm going to create 2 sets of parentheses. I'm going to take the first two terms together and the second two terms together, because if I look at all four of those terms right now, they have nothing in common. Well, if I look at my first parenthesis, my GCF is just A. My second set of parentheses, my GCF, is 3. So now I'm going to have A times and I'm going to divide each term. It's going to become 2A plus 3. We're still doing the same thing, divide each by A. Down here, this is a positive 3, so I'm going to say plus 3. I'm still going to divide 3 by each of the terms and get that. Now, this is where we want both the same in each parenthesis. If I look, 2A plus 3 and 2A plus 3. Technically, right now, we're factoring out a GCF. They both have 2A plus 3. So I have 2A plus 3, and I'm going to use what's left in front. This is going to be times A plus 3, because once we factor both of these pieces out that are the same, all we're left with is A and plus 3. Well, distributive property is multiplying, so now we're multiplying. If we look at our second example, again, I'm going to take two sets of parentheses around our terms, because although we could factor a 2 out of all those terms, let's group them together first. So now my GCF for my first set of parentheses is 4b, and my GCF for my second set of parentheses is 2. So now if I pull a 4b out, I'm left with b minus 3. I pulled out a positive 2 as my GCF, so I'm going to put plus 2, and I'm left with b minus 3. Again, I have the same thing in both sets of parentheses, so I'm going to start with that, and I'm going to use what's left to create my second set. So this becomes 4b plus 2. All we're doing, if I were to divide it like we normally do the GCF, those b minus 3's would cancel, and you'd be left with 4b plus 2. Our last example, again, in this case we can't pull anything out from all of them, so we're going to factor by grouping. I'm going to group those together and group those together. Well, from my first set, I'm going to pull out a 3a, and from my second set, I'm actually going to pull out a negative 2. That way my first term can be positive. You could also pull out a positive 2, but I like to pull out the negative to keep my first term positive. If I pull out a 3a, now I'm left with 4a minus 5b. In this case, I pulled out a negative 2, so I'm going to subtract 2. I'm left with 4a minus b. From here, our terms on the inside are the same. Oh, and I apologize, 10 divided by 2 is 5. So now we have 4a minus 5b, and I'm going to use what's left to create my second set, so 3a minus 2. If when you factor out the GCF, you do not get the same answer in the set of parentheses, you cannot just combine them. That's why we want to make sure we have the same numbers and the same terms with the same variables in those parentheses to be able to factor them out. Please bring your notes to class tomorrow. We're really going to focus strong on the first half of them. The second half, we're going to hit tomorrow, but we're going to really focus strong on that on Wednesday. So make sure you're bringing them both days, and please also bring any questions you have. I look forward to seeing you then.